computers are the ones, or what is it? Yeah, hey, I don't know nothing about it, so you tell me, man.
Okay, welcome back. The first thing I think everyone should understand is that we, as humans, are the blueprint for how these devices think. And I'm going to talk to you about three things right now. The first thing is going to be, how do we think? How do we conceptualize our thoughts and process information? The second thing, how do we go about problem solving? And then the third thing is memory. So those are the three things I want to talk about. And then at the end, I just want to tie a little piece and highlight how this parallels with these AI tools that you're seeing today. All right, so before we get into it, like for real, I want you to understand these vocabulary terms, and that is sensory input, cognition, and implicit and explicit memory. And then when it comes to problem solving, I'll pause there and I'll give you some more vocabulary when we get to that place. But starting with sensory input, what does that mean? So we as humans process information. Our data comes from our senses: touch, smell, taste, vision, and when we hear things. Another thing that I want you to understand when it comes to formulating thought is that there are different ways that we process information. We either synthesize it from our experiences that have emotion, or from factual knowledge that exists in the world. Things that are a little more abstract, like geometry concepts. So, going into that, I want to talk about natural and artificial concepts. In human psychology, when we're learning things, natural concepts in the world are, let's say you see two people that are in the street. And one of them looks very agitated, and you learn, something's about to go down. And through that experience, you learn, I don't want to get caught in that. So I'm either going to cross the street or go to the nearest place inside. And these are things that happen every day around us. Sometimes they're not always bad things though. Sometimes it's a natural organic experience of you see a big giant dog and you think it's going to be a little bit mean, but it turns out they're like a puppy and super nice and they want to rub all over you. So that's an example of the way that we develop these natural concepts of, okay, this experience is safe, or maybe I should avoid things like that. Then you can translate that to social norms. So when you go to parties, sometimes you always have to talk about things that might feel, how's the weather like? Things like that. So you learn that's a social norm. Nobody writes it in a rule book. Nobody prints it out on your birth certificate on the backside. That, again, natural experiences form natural concepts. Then you have artificial concepts that we develop as humans. You might think, what does that mean? Tell me more, and I will. When we learn these things, they likely happen in like a structured format. Either we learn it from a textbook, a classroom, a video course, but we don't come ready right off the bat learning. I know the periodic table from day one of my lifespan. That's not how it works. So these are things that we tend to gather as we navigate in different spaces. The concept of software engineering is an artificial concept that we've learned and we are continuing to learn about. So that is the first concept. What does that all mean? Let me tell you. It's giving them, word. Okay. So we have things like semantics, which are giving meaning to words. We have things like syntax, which is the way that we organize our words, like the order of which it goes in. Maybe there's like a repetition of it when we're writing poetry, or when rappers are creating their songs, they have these bars. They call them bars. Don't ask me, ask them. And they organize the words in certain ways that it causes a rhythm. Another cool thing going on inside your brain right now is problem solving. Everywhere you go, you've always learned to solve a problem, whether you feel like you're doing it right now or not. How does that happen? How do we know when we're doing it? How do we know what kind of problem solving needs to happen? And it really depends on the situation. So I'm going to tell you 3 common ways that have been supported by scientific literature on problem solving. The first one is the FAFO method. In the digital world, we call that the click around and find out model, which is literally you're clicking around with new tools and figuring out what works and what doesn't work. But no, for real, in the scientific literature, it's called the trial and error method. We literally try a series of actions until we find a solution that works. So that is something we've done since the beginning of time. And then, as we've evolved in our cognition, we also like to use algorithmic learning. That means there is a specific procedure or a series of steps that needs to occur in order to find a solution. And once you understand, okay, with these steps, I can get X achievement, you're able to replicate those same results. It's like a recipe. You're following the same thing, and every time you get the same dish. Okay, the third way that we problem solve is through general frameworks like heuristics. Heuristics basically mean they are general rules of thumb that we use, and through these rules of thumbs, they provide us with an understanding of what might work. Maybe it's not going to be exactly the same every time. You're using your own mental model, your own understanding of how you've solved problems in the past to solve current problems and face current challenges. So that's problem solving. And like I said, the last thing I wanted to tie into it was memory. How does our memory work? How do we store information? How does that information stick with us? And how the heck can we get better at this? It's a tough question these days because we're always bombarded with information. So our memory works in 3 general stages. The first is encoding, and that is receiving information from our sensory inputs. Remember we talked about sight, smell, touch, etc. All that information comes through, we encode it, and then we store it, and then eventually we are able to retrieve it. But it's a little more complex than that. Each stage has different things that happen in between. When you're encoding information, you have your semantic memory, meaning these are the way that we interpret words and language, and we formulate meanings. Then we have visual encoding, which is of course any images that you get from visuals, and acoustic, so that's from sounds. Think about all the media you receive today. Okay, you're going through your phone, you're thinking about what you're going to do next for dinner, but you're also distracted, but you're also thinking about work and should I be upskilling right now? What should I be upskilling on? Things like that. Okay, all of that. Imagine trying to learn and you're jamming sensory information in all your senses. Do you really think it's going to make it to that storage phase? Taking time to give your undivided attention to one thing at a time, one piece of information, however works best for you, so that you can move that piece of information into storage. So when we get to storage, there's a model called the Atkinson-Shiffrin's model, and it was first formulated in 1968, and it's still a very highly cited study today. I can show you more of how you would go through finding scientific articles and interpreting them and finding cited sources like that on a different day. But let's get into that model. In the storage phase, phase 2 of our grand scheme of memory, we have sensory input. So we get sensory information, it moves on to short-term information, and then it can get lost in the sensory memory state. You're taking information into your senses, so think about if you're trying to study right now and you've got a video game blasting in the background, maybe you want to find a quieter space. Whatever works for you, just know that at this phase, while you're receiving the information, you need to do something to move it into that short-term phase. And if you don't do it immediately after you get that information, it's more likely that you're going to forget it. Again, try not to keep it super technical, but we can make it technical if you want. I'm just trying to give you the gist of it. That last phase in storage is that long-term memory. So remember, moving from sensory to short-term and long-term. In that long term, you're going to have a running amount of information in your brain from like the beginning of time. From the time you're born to today, you have been storing and collecting information in the format of experiences, memories, and remember the artificial concepts as well, like just things that you've learned in class, technical information and stuff. And all of this gets to live in your long-term memory depending on what you do with that information. If you go out and about and you start sharing about your experiences, those memories get consolidated more so than if you just kept it to yourself and you didn't journal it or something to really let it sink in with you. Not everyone needs to do that. Everyone has a different format of putting it into their long-term memory. So with that in mind, in a nutshell, now I want to talk about how this all relates to AI. Well, like I said, we're the blueprint of how these systems work. Think about when you're interacting with a tool like ChatGPT, you are interacting with something that is called a large language model. So it's a little technical here, but let's go. Large language model meaning that this device was trained on all the language that exists out there, whether it be in digital format or it was in physical format, then translated to digital format and trained in a manner that these systems can detect and categorize information in a similar way that we do. All the information it has is all the information that we've given it, that we've put in the input. So when you're using a tool like ChatGPT, Claude, Gemini, DeepSeek, or if you're watching from France, Le Chat Mistral, I don't know if I pronounced that right. These tools are changing the way that we receive sensory information. And I hope that you carry this with you as well wherever you go, however this information helps you. Okay, bye.